All right. Hello and welcome back to Enterprise Linux Security episode 108. I'm here as always with my friend Joao. How you doing?
All good, Jay. As always, a pleasure. I know this topic is particularly important to you.
Yeah. Yeah, automation and configuration management is just one of those things I've been obsessed with. And when I go into my story of how my automation system came to be, it'll probably make more sense. But sometimes it's funny because sometimes I'll get into my Ansible system, I'll manage it, or I'll change some things before I start work for the day because it just gets me energized, which I have no idea why I like it so much. But when we were talking in a previous episode about how some companies, or was it most companies, they kind of at some point just throw their hands up when they're trying to automate things and it just never really gets off the ground. And then they just end up not automating anything. And I feel like automation is such a major benefit. It's sad when a company makes that decision, but I think the reason is because you really have to understand what goes into it, some of the considerations that go into it, so you can make a decision with you and your team, effectively understanding the scope. And once you do that, I feel like it's a lot easier, but a lot of people just kind of just dive in, not really thinking about it. Oh, I'll just learn Ansible. I'll just create some task books or playbooks and go from there. And it just sometimes it can be a circus, especially when you have a team of administrators that have his or her own opinion about the way things should be. And then you end up having to sell your ideas, and there's a lot to get into. So we have a couple of topics to get into before we get into the main topic. It's still to do with automation and configuration management, but I want to set the stage, kind of just kind of set some ground topics and some errata that we'll be talking about throughout. And first of all, what are we talking about when we say automation, right? So for people that are new, there's automation solutions such as Ansible, Chef, Puppet, and SaltStack. I mean, there's a number of these. And the idea is to basically automate things that you would do manually. Now, you could argue if there's a task that you're going to do and you're pretty sure you're only ever going to do it one time and then never again, you could probably make an argument to not automate that. But if you're going to do something repeatedly, for example, you want to have the same message of the day on all of your servers when you log in. If you have 500 servers, are you trying to copy that message of the day file manually to each one? Or do you just put it in the template? And then what happens if you need to change it, even if it's in the template, then you need to still go to those servers and make that change. Or maybe you have a text editor you want installed on everything, or more importantly, company policies that mandate certain aspects of your system, from retention policies to the default applications or whatever it is. You could have an Etsy Skell folder with config files. So when you have a new employee start, then they get like your development team's config file for the text editor that's got the right number of tabs, because we're all using tabs, not spaces. I'm kidding, of
Oui.
course. Actually, I use spaces, not tabs. But anyway, that's beside the point. But the basic point is you have things that either your IT team, your policymakers want to be the case and everything. But more importantly, if you have a server and it goes down and you have to rebuild it, you don't want to do that manually. You want to basically have it come to life with all the changes and adjustments that you and your team have agreed on needs to be the case, the things that are required for your web server to serve a website for your company, a database server to be on the back end of that. Maybe you want to set up a Nextcloud server and have that automatically be created. And then obviously if something goes wrong, you can just spin up a new one. There's a lot to do with infrastructure code. And that's more so what we're talking about here, defining in code the end result of how your system should be. And meanwhile, trying to eliminate as much of the manual work as you possibly can. That's pretty much the elevator pitch of what automation is and why we do it.
You'll often see this referred to as the desired state. You have a system and you want it to be in this desired state with this set of configurations, with this set of applications installed, this set of packages, and now you want to replicate that at scale across your infrastructure. That's where
Right.
automation is particularly useful. In addition to that, automation is also particularly useful because it's a growth enabler. At some point, your infrastructure, regardless of your team size, it doesn't really matter how large your team is. There will be a point when you have so many systems, so many different things to do, that you just don't have the time to do it manually. So inevitably, even if you're not very fond of automation, you will have to use automation. There's no two ways around it. There's not enough hours in the day or days in the month that let you do the tasks manually on every single system. So
Right. Yeah.
more so than just giving you the ability to repeat tasks and get that desired state every single time, it enables your infrastructure to grow.
And there's going to be some other tools we're not going to mention as much, but I just want to kind of mention them now because I know for sure people are going to ask about it. So people might say, well, you didn't mention Terraform, for example. I like Terraform, so there's nothing against it. I just kind of feel like where it fits in the best is to make things exist. And then a solution such as Ansible, Chef, or Puppet, more what we're talking about today, takes things that exist and then maintains them. Now, I'm sure someone's getting ready to write a comment, but Jay, you can maintain and make changes with Terraform and use that. Yes, you can. But in practice, I've seen many companies use Terraform, and it's always been discombobulated to use something like that to make regular changes, especially considering if there's a change that requires a new instance to be created. If you don't watch that, you could easily delete a server, then it recreates it, which might be what you want. But at the end of the day, I feel like Terraform is best used as the thing to create things with, and then not. After that, hand it over to your automation system. I don't recommend using Terraform for regular changes, especially considering, and I'm not going to get into it, but there's state files you have to maintain. And if those get out of whack, if you have multiple administrators that are using it, you could have conflicting state files. Then you start looking into how to centrally manage those state files so every administrator is pulling from the same one. But then with all that work, I ask why. When Terraform is good at creating things, you can even go into Terraform and hand it off to Ansible, Chef, or Puppet right from within there. And that's what I recommend people do. So I just wanted to acknowledge Terraform. I do think it's a great solution, and I think it has its place. We're more so talking about solutions that are dedicated to maintaining things. And yes, Ansible can create things as well. But again, let Terraform or something like that create things. Let your automation system take things that exist and maintain it from there. That's just a personal recommendation. So I just wanted to acknowledge that.
And if you don't particularly like the tool choices that we mentioned, never forget that automation can be done with simple scripts. You can use Bash, you can use Python, you can use PowerShell if that's your poison. You can use whatever tools you want to create those scripts. It doesn't really matter. The tools themselves, the ones that we're going to be talking about, those are just wrappers around simple scripts. Those are just facilitators for the task. They don't define automation themselves. They make it easier. They give you a set of standard ways to approach automation. But at the end of the day, you can do just the same with simple scripts that you apply to your infrastructure.
Right. And so basically, we've already talked about this, but I kind of want to just maintain this. Like, you really, when you implement infrastructure automation, and we're going to get into the specifics. We're not even at the top 10 list because the title of today's episode is 10 tips for effective automation. We haven't even got to the first one yet. This is all just precursor stuff. When it comes to working with a team, sometimes it's really hard because, we're so passionate about what we do as sysadmins. We really love it and we believe in it. We also have really strong opinions. So sometimes it could be really hard to get buy-in, as we'll talk about later. That's extremely important. But I bring it up now because I feel like people should know about this as they're getting into it. Not that there's anything wrong with people having opinions, but if you have an idea for your automation system, you should probably be prepared to give some points for why you think it's a good idea, to let people know where your headspace is, because the infighting in a team could easily destroy the entire project by itself. So just keep that in mind. It's meeting with your team, having open discussions, trying to keep the discussions on point, and more than anything, understand the goals of what you want to achieve and discuss it based on the goals. You want to achieve these 10 things. Okay, then what solution will help us get these 10 things to be resolved or met? So just keep that in mind as we go through, and understanding the scope is important. I mean, some people, well, I'll just automate a web server. That's fine. Okay, now you have to add a database server. Now you have to add Nextcloud, or maybe you want to automate a Kubernetes cluster or something like that. When you start thinking about all the things you automate or want to automate, you could kind of more understand the scope. Otherwise, you think something's easier than it is. You think it's going to take a month when it takes a year. I mean, you really do have to understand this and have clearly designed goals for your infrastructure. I think that's really important to have. So just another thing to keep in mind as we go through this.
A good point to start that discussion with your team. Identify the stuff that's repetitive, the tasks that you're doing day in, day out. Make a list of
Yep.
those. Make a list of the things that take the longest. Make the list of things that are very easy to make mistakes at. If it's very easy to mistake the list of packages that you want to upgrade or that you want to deploy, get
Yep.
that list written down, and that's a good way to start a conversation. And then identify what you want to achieve with that. Do you just want to make it consistent across all systems? Maybe that's your goal. Or you just want to reduce the errors that sometimes happen, or just make it faster, or just make it, again, more consistent. That's the way to approach the initial discussion with your team when you're approaching automation.
Yep. And so getting into my choice before we get to the top 10 list, I don't think it comes as a surprise to anybody that I use Ansible. I think I've mentioned that only about approximately 9,999 times during the podcast. So I think unless you're new to the podcast, you probably already knew that. I thought it'd be kind of fun to kind of real quick, just kind of talk about how that decision came to be. So originally, before Learn Linux TV was a company and it was just me doing videos in my basement, I didn't have much. So I had one computer, and when I reviewed a distribution, for example, I would wipe it, install that distribution, load my programs on it, and use it for a week. And then after I do that, then do a video about it. But it just got so annoying. And sometimes I would just not look forward to doing the review because it's like, well, I'm just creating a bunch of work for myself, because after I do the review, then I go back to my whatever my chosen distribution is at the time and reload everything. And eventually I created this monster bash script line by line. I don't even think it had a single if statement at the beginning, where it was just like, sudo apt install this big wall of text with like 100 packages on one line. It was dreadful, but it works. And I think a lot of people do that, where they kind of start with the bash script, and then they might have a vimrc file that they put in the same folder as their bash script, and then they install that. And then eventually they get tired of copying it to each machine, so then they learn version control, so they can have their bash script in a single source, and they could just git clone and then run it. And then eventually this monster script, I don't even remember how many lines of code it was, but it did everything in bash that I needed. And it put the fun back into doing distribution reviews again, because I no longer had to worry about reloading my system. I don't care. I'll just run the script and everything is on there. I had all my files in network storage, so I didn't really care about losing any data. I just needed to get my programs on there. So it made it like really easy to get everything back to the way that it was. And we're talking a really long time ago, probably over 10 years ago. So then I go and I get this new job and they want to use Puppet. So I'm like, okay, I'll learn Puppet. And I did. And I implemented Puppet at the company, which was a lot of fun. And then I also figured, well, if I'm going to use it at the company, I may as well use it at home. And I think this is where Home Lab really kind of starts to get really popular, because you have a solution at work and you have systems at home. So what's better to learn a new thing than to implement it at home on the stuff you already have and make it bend to your will to do the things you want to do. And one of the things about Home Lab is that it's really rare that you have two people in your household that are interested in Home Lab. Usually it's just the one person, and that's you. So you'll just have all the control, like whatever decision you want to make. You don't have to talk to anybody. You don't have to meet with anybody. And through this control, you can implement it quicker, learn it quicker. And then when you go to work the next day, it's like, oh, I learned this new function in the automation system. Check this out. And then maybe the team might think it's a good idea, and they might give you the blessing to implement it. And that's kind of how it played out for me. But then, long story made short, that company went out of business. I was really sad because I loved working there. I had a job pretty much immediately, but they wanted to use Chef. So naturally, I learned Chef, and I get that implemented. Actually, it was already implemented. I was maintaining it. But then, of course, I change everything internally to Chef because I'm like, I may as well. It's the best way to learn it. So then I converted Ansible to Chef. And as a humorous note, I even had in Puppet an instruction to have Puppet uninstall itself after installing Chef. So I literally put a commit into Puppet that made it decommission itself and install Chef. It was great. I thought that was pretty funny. But then later on, I discovered Ansible, and I really liked how it was lighter. The syntax was just, far fewer lines of code. And Ansible is just great. I love it. Now, obviously, everyone's results will vary. They have their own preferred solution. I'm going to probably talk about a lot of the things in the top 10 list in scope of Ansible, just because it's what I spent the most time on. So I switched to Ansible probably back in 2016, and I've been maintaining the same internal automation system since then. And now we're going to get into some very interesting facts about my automation system. Now, I did release a very early version of this publicly on GitHub a long time ago, but the current state of my internal automation system is way more than that. Like, it's that whatever I have in GitHub right now is just a small fraction of it. There's 380 playbook files in there. There's 80,000 lines of code. 80,000 lines of code, all written by me. I don't have a team yet. And, it's just me doing all this system administration work. So I have personally written probably way more than 80,000 lines, because there's going to be roles that I've implemented that I no longer needed, or I found some duplication, so I removed something. But now, obviously, I don't want people to think that they too will have to write a solution with 80,000 lines of code. I'm a bit of an overachiever because I'm obsessed with this, and it is something that I really enjoy doing. So I automate everything I can possibly get my hands on. But 80,000 lines of code is where it's at. I wouldn't even think that most IT teams would probably hit that many. And some people are probably thinking, are like, over 380 playbooks? Are you insane? Maybe. But that's literally where my internal automation system sits right now. And I didn't even know this. It was like 2 weeks ago, I went into my roles directory and I did find files, and then, did a pipe it into a word count -L or WC -L to get a line count. And I looked at it, I'm like, what? I wrote that much? Yes. You'd be surprised. But then again, I've been writing it since 2016, but I feel like, this is something that I like to talk about. And after having done that, I could talk about the challenges and the lessons that I've learned and the things that I've gone into. So that way, maybe you guys won't have to run into some of the things that I did.
It's interesting, but that level of, actually, that number of files and that number of lines of code, it's part of the reason why people are often reluctant to change their distributions and change their tooling. It's because they have so much stuff built around the distribution choices that they make that it's really tricky to move out of it.
Yeah.
Part of that explains why people freaked out when Red Hat made those changes to CentOS and end-of-life CentOS. And the reason is precisely that. People already had their own ecosystem and their own environment built around CentOS, and CentOS would no longer be available. Having to maintain so much code and so much work that has already been put into that, and instantly losing all of that because it becomes worthless if it cannot be applied to the new distribution that you pick, is the reason why people freaked out. It's why Rocky and Alma Linux came out and they have so much following right now. It's precisely because people could continue to use whatever stuff they had for CentOS, and they can continue to use it. Sometimes this doesn't come across in the discussions that people have when they're discussing their distribution choices. Oh, we'll just pick whatever is the latest and greatest right now. That's not the best idea. You need to be able to make sure that you're not throwing away all the work that came before. So
Right.
moving to something that's at least compatible to what you had before, that's probably a better idea than just moving to something that's based off, say, Debian, and when you were based off of Red Hat before. That's
Right.
part of the reason, a very big part of the reason.
I'm so glad you brought that up. And for the longest time in the podcast, and I still maintain this now, every organization should have a plan B distribution. And no, I'm not saying I have any inside knowledge that anything is going to happen or anything like that, but we see this happen where a distribution changes the next day, where they go a different direction, and maybe that's not the direction that your company wants to go. And with CentOS Stream and all of that, nothing against CentOS Stream. I mean, for some people out there, it's probably a great solution. For other people, it's just not the direction they themselves independently want to go. And then they come up with a fork in the road, and they have to forge a path through a new distribution. But it's easier early on. Obviously, if your company has been in existence for a while, adding a plan B distribution is a lot of work. But if you can, and you're within the ability to do that near the beginning, I think it's like a dream job for a lot of sysadmins to be employed at a blank slate and be able to just, paint the canvas any way they want. But having a plan B distribution is important, just in case something happens. And this was always part of my automation system. I'm pretty sure it was Ubuntu and Arch. Yes, Arch. I can't believe I decided to wrangle that one. But everything I did in one, I did in the other, as I was designing it. So if I had to go one direction or another, I could flip it. And that's always been a part of the design. I never wanted to have all my eggs in one basket. And now, as it stands today, my automation solution internally supports Debian, Ubuntu, Fedora, Alma Linux, OpenSUSE, and I'm sure I'm forgetting a few. There's like 6 or 7 distributions that everything I do in the code base will apply to each. And I'll talk about, and no, I don't think anybody should have that number of distributions. The only reason why I do is because I cover Linux. So obviously I need to have more than most, because I need to be able to spin up an OpenSUSE system or a Debian system anytime I want it and have certain things in place. So obviously that's not something I'd recommend other people to do. But I think the main point is, when you're developing an automation system, if you can support more than one, do it. Sometimes it's easy if you're supporting both Ubuntu and Debian, where the differences aren't that much. But like you said, if you are supporting Ubuntu and Alma Linux, or Ubuntu and Fedora, well, you're going to have a little bit more work to do. So you got to kind of think of that as well. But those are some interesting facts about my infrastructure, and I'll probably talk a little bit more about it later as we go. I'll probably throw a few in, because I know a lot of people are kind of curious what it looks like behind the scenes. So I thought I would give somebody that information. Another thing I wanted to mention real quick, and then I think you mentioned this word that's impossible to say, idempotent. I always have trouble with that word, so I definitely want to give you a chance. Idempotency. Yeah, no, I don't know why I have trouble with that. I just want to plug my Ansible course real quick. I mean, I kind of feel like this is the best time to do it. So I have a Udemy course that covers getting started with Ansible. After the podcast is posted, I'll make sure that there's a link in the description if there isn't already. If you just search for me on Udemy, you'll find it. So check out that course on Udemy for getting started with Ansible. But I wanted to give you a chance to talk about idempotency before we get started with the top 10 list, because that's a topic that I think should be at the center of everything we do.
Yeah, so idempotency is a concept that comes from maths, from functions, but applied to automation is the ability that you have to run a particular script or task or playbook or whatever you're using on a system, and it does whatever it's supposed to do, and then you run it again, and it doesn't mess up that system. It will detect that the changes have already been done, and it will simply report all done, and that's it. Why this is important is, imagine that you have a script to deploy a specific configuration file, a specific configuration change to a particular configuration file, and you run it against, say, 200 or 300 servers, and for some reason it breaks midway, and now you have to restart it. If you run it again and you're not worrying yourself about this, then you're going to have files that have 2 times the change, and that might break the services that are using that configuration file, and can leave you on a state that it's not very easy to recover from. If
Right.
you design your scripts in such a way that they first check to see if the change has been applied, and only if it hasn't, they do and apply that change, that will protect you against this. This is a common mistake when you're designing your first automation scripts and your first deployment scripts, where you don't consider this. And then when you're testing the scripts, you're applying and reapplying and applying again all the changes, and it messes everything up. So pay attention to
Yep.
that. Make sure that your
Yep.
scripts are protected against it. If you're going to make changes to a system, first check to see if the change is already there or not, and only if it's missing do you apply that change.
A very, 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 very common trigger for this issue that I have seen more times than I can count is when you have a config file and you want to uncomment something inside that config file. So you write an instruction to take the hash symbol out of the beginning of it. If you code that wrong, it's going to keep adding that same line of code over and over again. And what you'll end up seeing is you make the change to your automation system, you run it, it says changed equals 1. And you're thinking, great, I did make a change and it shows 1 change. That's great. Run it again without making any changes. Just rerun it. If it still shows a change, that's a red flag if you didn't yourself make a change. So if you didn't make a change, and it's already run the most current version of your system, then it shouldn't be making any changes after that unless you have made a change. And if you see every time you run something that it's always changing something despite you not making changes, you should probably look into that, because that is often a red flag that there's something going on. And you might open up a config file and see the same config item like 10 different times. And every time you run it, it's adding it again and again and again. And to your point, the service freaks out because if you're lucky, it's just going to take the last occurrence of that and use it. But if you're not lucky, it's just going to bomb. So that's definitely something to watch out for.
Again, common pitfall there. So beware.
Yep. All right. I think we're ready to get into the list, starting with the first item. And there's probably going to be way more than 10. I mean, we had a lot of trouble getting this down to 10, and we're probably going to mention, oh, how about this? Oh, how about that? And it's probably going to balloon up to 15, but we're calling it 10. So the first one is to choose your solution carefully. Basically, research the available solutions like Ansible, Chef, Puppet, SaltStack. I know there's others. And just try to understand the pros and the cons of each. Ansible works the best for me, but that doesn't necessarily mean that it's the best fit for your company. Some companies might actually mandate in policy which one to use. Maybe you join a company and they already made the policy to use Chef or Puppet, and you don't even have a choice, depending. In your home lab, you always have a choice. But if it's up to you which one to use, and you want to pitch this to your team, it's important to understand the pros and the cons of each. So Ansible being agentless is, I'm super summarizing here. Chef and Puppet have agents. I haven't used SaltStack much, so I really don't want to comment too much about that because I'll probably say something incorrect. But ultimately, it's just about, figuring out what's out there. And I realize now that I guess I covered some of the bullet points underneath the first option here, where I talked about my mindset as far as, what I've used before and switching to Ansible. Again, I just like how Ansible feels lightweight. To be fair, Ansible can get heavy if you excessively implement things. Like, even with as big as mine is, I try to make sure that everything I put into it has a purpose. And if I'm not using, and I regularly audit this too. So if I see something that I'm no longer using, like, oh, I'm not using that app anymore, I'll just delete the role right out of there to make sure it only has the things that I'm into. But beyond that, I found Ansible to be a lighter weight solution, so that's why I went with it. But don't just take my word for it and use Ansible just because Jay uses Ansible. Just check the other solutions. You might find that something else works better for you, so you might want to just spend some time on that. And I think that's really important.
Myself, I use both Puppet and Ansible depending on the situation. But the main thing here, I believe, is that it's not a deal-breaking decision there. If the place you're working at decides that it's something else, don't take that personally. It's not against you. It's not a fundamentalist decision. Just go with it. All of the tools will eventually give you the same result. Some
Right.
will need to massage more than others, but you'll get the same job done. It doesn't really matter the specific tool. As long as you know a few of them or just one of them, you can always pick up on the others. It's just slightly different syntax all around, but again, you'll get the same results regardless of the tool.
It usually comes down to whether you're using Ruby or YAML often, because it's going to be probably one or the other unless your solution uses something else. Like as a side note, YAML is probably something to understand the basics of, even if you don't go with Ansible, because there's going to be times config files in applications that have nothing to do with Ansible are switching to YAML. YAML is not specific to Ansible, just like Ruby isn't specific to Chef. So some of the I'm not telling you to learn Ruby, but I do recommend learning the basics of YAML, because you absolutely will run into YAML whether you use Ansible or not, and I promise you.
And you'll learn to hate spaces and tabs regardless.
Right.
So.
You will. That is so true. Now, the second one here, because the first one was short, because I already covered most of it during the intro, but the second one is going to be the longest. And the theme of the second one is to make things easier on yourself. And there's several subtopics here, the first of which being create a manageable directory structure. Okay. The thing is, yes, my Ansible solution is massive, but I never have trouble finding anything. I can always find what I want because I have a consistent directory structure everywhere. If the playbook, for example, makes a system-wide change, it's in the system folder. If the playbook installs packages, it's in the package folder, for example. And you could think of your own directory structure. You don't have to use mine. Now, the thing is, it wasn't always like that. There was a lot of inconsistency in my solution, and I spent a lot of time trying to find things, and then eventually, long before it's as big as it is now, I audited the whole thing and made sure every role had the same directory structure as much as possible. So if I'm looking for a template, it's in the templates directory. Inside the templates directory, there's a system directory. So it could be a system tweak. It goes in there and so on. It's just about making things easier on yourself, not just you, your team. As we'll get into documentation later, that this doesn't undo that being important. You'll still need documentation. You'll still need to train your team. No amount of organization is going to stop you from needing to train people. That just happens. But if you have things in a easy to predict place, it makes it that much easier to find what you're looking for. If you need to tweak a package or tweak a config file, you'll have a general idea where to look for that. And I think that's very important, especially as your solution eventually grows and you add more playbooks and it expands. Keeping that under control now rather than doing a mass audit. And let me tell you, when you audit an automation system and you move files around, you will find out just how much it's going to break. And it's going to break in glorious ways that you won't even believe. And I know this because I've experienced it. That's why I recommend at the beginning, if you are in a position to implement something for the first time, you should probably just keep that in your mind as you're doing it. Where would you logically look for an SSH config file? Where would you logically look for a vimrc file or whatever it is you have, your etsyissue.net or your message of the day and so on? You know, where do these things go? Where would you look for them? That's the idea.
Also, complexity in storing stuff is one thing if you're doing it on the home lab, and it's completely different if you're doing it as part of a team. Make sure that everybody understands the logic behind the decisions that you make, like, say, as you mentioned, keeping the system-wide changes underneath system, but make sure the entire team knows about it. Another thing that is really good and is going to help you and make your life easier for you, use source control to keep those files. For one, you get the backup for free somewhere, but additionally it gives you versioning and a whole host of different things that's pretty good when you're editing files and you might break stuff. Being able to roll it back is a lifesaver.
Yeah, and as we're going to talk about later, I'm going to give examples of how I use version control. Version control is actually at the heart of what I do. Like, it is probably the most important aspect of it, because the repository becomes the single source of truth for everything. It's where everything is, it's what everything's based on, it's where everything gets pulled from. So it's a single source. So I absolutely agree with that. Now, the second one, subtopic here, I think it's second now, I lost count now, but I want to talk about the concept, and this is still in line with keeping things easier on yourself, of using clean images. Now, I'm going to give you a scenario why that's important, because I think this will kind of help people understand why I'm bringing this up. So say, for example, you have a team yourself and two other administrators. So you have Bob and Sue. I have no idea why I made up those names, but we'll just go with it. And they work with you, and they're fellow administrators, and the three of you are maintaining this. And let's just assume, for the sake of argument, it's going really well. There's no problems. Everything's fine. So then you get the idea, well, it would be great if our user accounts were baked into the image. So that way, when we use a template or an image, it has all three of our user accounts in there. So that way all the administrators can log in immediately. But what happens then if Bob or Sue gets a job offer somewhere else? Now you have a user account in your templates for a user that no longer works there, which is a massive security risk if you let user accounts kind of just sit around there. And then you got to go in the templates and remove the user account of the person that left. And then you have to, well, you already should be maintaining users within Ansible, or not Ansible, but whatever it is you use. But when you think about, and I think this is how most people think when they go through this, like as they go through and navigate this, they're going to try to pre-run their automation system in a template. The logic being, when you create a new instance with that template, the automation system is already run once, so it only needs to catch up with whatever changes you've made since you made that image. But you're going to decommission packages. So you might have something installed that you don't intend on using anymore, that you may have thought back then was a good idea, but it isn't something that you use anymore. So now you have like you create technical debt by baking everything into the image. So I don't recommend that. Recently, I don't know, this last year, I think it was, I made my internal solution work against clean images. And what that means is you can get an Ubuntu ISO, install it, or an Ubuntu template, Debian, Alma Linux, whatever it is, and it contains no configuration at all. It's just straight, it's just the distribution. Even the bash prompt is unconfigured at this point. Like there's nothing configured, but as soon as I run the solution, it catches it right up, and I don't have to worry about artifacts of a previous mentality being in the image, because then you get into a situation where you're redoing your templates and your images over and over again because you keep making changes, and then you're spending time adjusting that. And obviously this could be a bit of a controversial opinion, but I've had some companies, from a security standpoint, their policy is that it has to be a clean image from the distribution to start with. So my recommendation is to try to develop it in a way where it's going to it's going to build your instance into what it needs to be from a fresh distribution blessed image, because I feel like that's going to be, in the longer run, create less technical debt for you. Now, obviously, you might still have to go into your automation system and clean some things you decommission, but at least you don't have to remaster your templates, which is a big chore, believe me, I know.
Absolutely, you'll get nothing back from me there.
Now, another aspect of this that I want to talk about, and this is going to be specific to Ansible. It's been a while since I used Puppet or Chef. I'm pretty sure they have the same thing. Register versus handlers. And we can insert whatever terminology for Puppet or Chef we want to, if that's what we're using. But think of it this way. You have a config file, and let's say there's 10 changes you want to make. Now, obviously, you could decide to use a template, which is a good idea. Or maybe you just feel like, especially with a config file being different per distribution, you might think it's a better idea to just, uncomment the lines that need to be uncommented. So you write that. And then for each change, obviously, any one change, you're going to want the service to be reloaded or restarted. Otherwise, it's not going to benefit from any config changes. So then you start to think, okay, I'll implement this change and then restart it. Now, it's too easy to make it restart after every change. Now, if it's a one-off, that's different. Now, what's register and what's a handler? So a register in Ansible, for example, is to register that something has changed. So if you have an instruction that uncomments something, then right underneath that, you might register that as a variable. And then right underneath that, you might say restart service when name of variable dot changed. But then you might have another change to that same file further down. So then you do another register, and then you do another change, and then another register and a change. And maybe the change is to restart the service. So then you have the service restarting 5 times in a row if it's making all 5 of those changes, which isn't really clean. Now, for a one-off change, and you're sure you're only going to do one change, that's fine. But register, on the other hand, a handler, I'm getting the terminology crossed, a handler on the other end of this is going to restart one time, no matter how many changes were made to the file, it's going to do it at the very end. So whether you've made 3 of those 5 changes during a provision run or just one of them, then it notifies a handler, it restarts at the end just one time, no matter how many times it changed. So this is kind of something to, when it comes to restarting services, reloading services, when is the best time to do it? Another example of this is you install Apache, and then maybe you have that register, and then underneath that you have a task for systemd enable Apache when the previous one is changed. Now that's okay, because you just want to make sure that it's restarted or enabled anytime you update the package. So you could probably argue that's fine, but some of this might be advanced for people that haven't used Ansible before, but the idea is to handle restarts gracefully at the best possible time, and try not to restart things unnecessarily or too frequently when you could get away with one restart of a service. Obviously, some things might be installed in stages and need that, but as the administrator, it's just about handling this effectively, so that way you know that you're not excessively doing anything that you don't really need to be doing. So just keep in mind when to use the different functions of your automation system, because they might seem like the same thing, but they're different. So it's just understanding the differences in the functions, and there's going to be overlap where you have a restart and a reload. It's kind of the same thing, kind of not. You have a handler versus a register. They both can restart services, but just basically make intelligent decisions when it comes to the design. And I will hydrate. So now we're up to number 3. And I think I've touched on this a lot, but when to use templates versus files. So a template is a file that has, and they're Jinja 2 templates in Ansible. I don't remember off the top of my head what they're called in Chef or Puppet, but the idea is you have this config file with placeholders inside of it. So if you think about your SSH config file, your allow users might be a variable, because you certainly don't want the same users to be able to log into all servers. That would be bad. You want principal least privileges. But you could have a variable for allow users, and then per host, you decide which users are allowed to sign into that. And that placeholder gets replaced with the usernames that are allowed to log into that server. If you do a flat file where you just kind of hard code the usernames in there, then every server is going to be accessible by the same people. And that's probably not what you want, especially considering that if you're working as an MSP and then you have a project manager that needs to log into a server, even if it's read-only access, you certainly don't want to allow that user access to other companies' infrastructure. That would be really bad. So a template file lets you essentially create a variable in place of a config file setting what it equals, and then have it different per host. And I think that's something to get in, to make good use of, especially at the very beginning. And go ahead.
It's dynamic versus static. If you need the same configuration across all the systems, you use a static file. If you want slight changes between them, say depending on their host name or depending on where they're located or their something else, their IP address or something like that, you can use a template, and then that will be filled in as a variable.
Now let's look at a situation where you may not benefit from a template. And I keep using this, but the message of the day, or etsyissue.net, basically you want a message that shows up when you first log in. And this is a very common policy at organizations where it's mandated that you have to show a message when someone attempts to log into a server that unless you're authorized to use this server, it is unlawful, you must stop, or something like that. I think all of us have seen this within the first couple of months of being a Linux admin. Now, if it's company policy that every server has to show that message and it's not different per server, it doesn't make sense to make it a template. Just make it a flat file. And then you could just simply update that one file. Not everything has to be a template. It's about finding out what is dynamic versus static. The message that shows up when you use SSH, that's static. The OpenSSH config file itself is not, and nor should it be, especially considering every distribution is going to have their own defaults anyway. So you have to kind of have a thought process about what is static, what is not. So that way you know when to use a flat file, because there's going to be an instruction in your config management solution to just copy a file as is. And there's going to be a separate one that's kind of the same thing. It's still copying a file, but it's called a template. And then it has dynamic values within that that are different per host. So I think that's definitely something to keep in mind.
The next tip is something that's especially atrocious when you have a diverse environment where you have Ubuntu stuff and you have Red Hat stuff and HTTP versus Apache. Man, that really is a mess. It messes all of your scripts when the same package has different names. So yeah, it's a pretty good idea to have package names not directly mentioned in the scripts themselves, but used as variables.
That's kind of how that is how mine works. So when I started implementing other distributions, it was a chore. I had to go through every file to find out what's different per distribution. Eventually, what I did was just make package names a variable. So instead of saying install Apache 2, well, that's not going to work on Alma Linux because it's HTTPD on Alma Linux. That's not going to work. So what I would do instead is Ansible Apache package, and then I have a variable file per distribution that is going to call out what those package names are for that distribution. So I only really need to maintain the distribution variable file. And it kind of worked because I think it was that I implementing Alma Linux after implementing Fedora. It was easy. Or was it Debian? Either way, it doesn't matter. Implementing another distribution was just a matter of updating those package names. So I realize we've been going on for a while. I can't believe how much time we've been recording so far. So I'm going to try to get through the rest a little bit quicker. I think some of them are shorter anyway. Building a development environment. Now, especially when you have multiple distributions, or even if you don't, you need testing instances. You need a lab environment, a development environment, whatever you want to call it, where those instances get the changes first. I mean, you really should not be pushing config management changes directly to production. You should have sample servers that are not accessible from the outside, that are in a lab environment, IP locked. And those are the first ones that run it. And based on what you see there, you could choose to graduate that or not to production and kind of test that out. For comparison's sake, I have 3 branches: testing, production, and stable, going from the most likely to break to the least likely to break. And my mentality has been, if users touch it publicly, it's stable. Okay, I don't. That's beyond production. Okay, I don't want to mess with that too much. That's going to be further out. So I make a change into staging, graduate it to production, and then production graduates to staging, which also means staging, testing, I have different names for it, is always at least one major version behind of everything else, because I just really don't want there to be that much change. But the benefit of this, and this has happened, if you implement a change that breaks something, you really think you did it right, and you're sure of it, you looked at this for a long time, and you are absolutely positive that there's no issue, you push it out to production and then watch things fall over, okay? That is not a good thing to happen. No matter how good you are not going to be in a situation where you'll have no failures. So you implement it in a testing environment first, and then eventually graduates. And that's exactly how I do it. I just have sample for every distribution my solution supports. I have a reference running server internally that is checking out the testing branch repeatedly. And as soon as I push something to my testing branch, I start getting notifications on whether or not it was successful. So I have a general idea if I did a good job or not. So and I think that kind of also takes care of number 6 in a way, because I just realized we're kind of talking about the same thing with that.
Just one aside there, if you don't get why that's important, rolling out changes in a tiered system, you should apply to work at CrowdStrike.
Speaking of that, I actually, as much as I hate to admit this, earlier on the development of the system, probably before my internal solution was 1.0. So it was like, excuse me. So before it was 1.0, it was 0.0 something. I implemented a change that wiped the entire file system on everything it touched. As systems checked it out, they were killing themselves. The main website dropped. The community forums dropped. I mean, I watched and I was like frantically trying to stop the rollout process. And then I was just watching server by server by server just drop. And now I have really good backups. So it didn't take me very long to get everything back up and running, but it was one typo. And I was just like, oh, yeah, I'm sure it's fine. I'm just going to just push it right out there. I never did that again. I have never made that mistake since. And I don't want anyone else to make that mistake either. I literally watched the entirety of the root file system get dropped on everything it touched. So that is why you don't commit directly to production. Okay. Just want to get that out of there. And number 6 was basically the same thing, just graduating changes out. And that's what it is. I think Microsoft calls it rings. I'm kind of out of touch with Microsoft these days, but they have this ring mentality when it comes to Windows system administration. Isn't it like ring 0, ring 1, ring 2, or something like that?
That's something different. That's the security level of the kernel stuff and the applications and the drivers.
Okay, I thought they did have a terminology that had to do with updates as well. But either way, the point is to graduate things to where they need to be. So moving on to number 7. The thing is, I don't have any administrators on staff right now. I just do it myself. Eventually, I'm going to have to do that, but I also really enjoy it, which is why I procrastinate. But I do develop my internal automation system in a way that would be friendly to other administrators when I do get them, because I want to basically try to prevent situations, but also just kind of make sure administrators know what's going on. So this is twofold. So first of all, a lot of people don't know, or I don't know, I'm sure a lot of people do know this, but there's something called systemd inhibit. And what that allows you to do is prevent a system reboot or shutdown while something is running. Okay. So immediately with my automation system, I use this because when it's running, I want to inhibit, shutdown, and reboot. Because the last thing I want to happen is, the automation solution, let's just say it's installing Apache and it's halfway done, or worse, it's updating the Linux kernel and it's halfway done. And then another administrator doesn't know that that's happening and they shut down the server. Well, now I have a half installed kernel or half installed packages, or the package database is broken. So what I do is inhibit shutdown. So that way, when the automation solution starts, it locks shutdown and reboot. And then when it ends, it releases that. Another thing that I do is I display a wall message to all users. Whenever the provisioner starts, it's sending a wall message to everybody logged into the system that says the provisioner is provisioning the system right now. And that way, if someone's on there, or even if I'm on there, I'm not like, why is my server so darn slow right now if it's really churning away? Well, I'll see a message that my automation solution started, and I know it's happening, and then it shows another message when it's done. And I think that's a good idea, especially for administrators that are heavily using the command line, because they're going to want to know what's going on in the server and be fully aware of that. So the 7th item is just be nice to your fellow admins, keep them informed of what's going on in changes you want to make. Make sure they're aware of where the automation system is. Of course, we can mention alerting and things like that. I use something called healthchecks.io, which is able to send you an alert if something hasn't run, so something doesn't silently fail. So if my automation system hasn't run on a server in over a week, and that means healthchecks.io didn't get a ping from that server, then it sends me an email to let me know. So it's just about understanding where things are and also just keeping everybody on the same page.
A good idea there is to have an email message go out to your team whenever you're starting a deployment of new tasks, and then when it ends. Okay, I'm starting this, it's going to do this, this, and this, and then a few minutes later, okay, this task is done. That way everybody knows about it, everybody is alert, and nobody freaks out when systems start to reboot for no reason.
Yep. And moving on to number 8, I think this is probably pretty simple. We won't have to spend too much time on this, but it is important enough to mention. Provide training and documentation to your team. Okay. No, it's not the case that code documents itself. Yes, it kind of does, and good, well-written code should be pretty obvious what it's doing. but we can't assume that everybody thinks the same way. We can't assume that people are going to glean exactly what's going on just by looking at the code. But I could also argue they shouldn't have to. There should be documentation for how to install it, how to make sure that it's working, what are the
Yeah.
components that are being used that makes it work, where are those components located, what's the logic behind how often it checks in, what are the names of the branches that are in the repository. Those are all really good things. And then once you have the documentation, sit with your people and make sure that they understand how to install it. And you know what? Based on their feedback, you might even find ways to simplify the process. So making it a two-way conversation makes it even better.
Another two things that I also like to document on this type of things is the impact that it can have on the system. If it's something that needs a reboot at the end, if it's something that's going to stop systems that are services that are running on the system, if it's going to boot the users that are logged into the system for some reason, and also the conditions that it can cause it to fail. For example, if it depends on a different system being online at the time where it picks up some external files for some reason, or if it's reading a table somewhere, then it needs to be documented that if those systems are not available, then this will fail, and it will fail because of that. And people might be surprised if they're not aware of it, and it can make them waste a lot of time trying to figure out why it's failing. So if it's documented, then people are at least have a place to look for the reason for that.
Include known issues as well. If there's something that you run into, or maybe something you haven't fully fixed yet because you're still trying to figure things out, whatever it is, just have known issues, especially like you said, things that are likely to go awry. Now, the ninth item is extremely important, and we kind of touched on this a bit, but I wanted to give it its own section because you have to get buy-in from your team. You have to. Otherwise, it's just never going to get off the ground. And I don't have any statistics right in front of me that tells me that it's the biggest reason for something like this failing. But I really do kind of think it's going to be definitely in the top five at least, where infighting can stop something. And the way that I like to deal with this is to show a proof of concept. I mean, it's one thing to go on a whiteboard and draw some halfway straight squares and some lines connecting them and try to get them to understand where your thought process is. But if you could build a proof of concept of a function or something and then say, hey, look at this, and then show it work, show the code, I find that often works because sometimes when somebody is arguing about why they don't think something is a good idea, the idea that they have in their head may not be how it actually is in your mind. So by showing them something, even if it's just pictures or something that works better, just try to massage things in a way that's going to make sure that they understand your mindset and where your headspace is, because a disagreement or miscommunication can easily cause something. But getting everybody to buy into it and to support it is easily going to make or break whether you even have an automation system at all a year from now. Okay, because you may not. Maybe people will throw their hands up and say, you know what, this is too much work. We're spending too much time on this. You really want to kind of at the very beginning understand the scope and try to avoid anything that's going to make it unmaintainable, or at the very least just make sure everyone understands where the thought process is, and that you have an effective way of communicating that, because that's really going to make or break it.
This actually transcends IT. It's something that's just common knowledge, but making sure that people are happy with the decisions that are being made really gets them involved into the process. It's why training the rest of the team is important. It's why being nice to the other sysadmins is important. It's why keeping them informed of what's happening is important. It's to make people feel empowered in the process. And like you said, unless everybody is behind this and you do have that weird guy that, oh, I'm not going to do automation, it's just a mess, and he's going to start introducing changes on systems that you're not expecting, and it will
Right.
cause the system to fail somehow. You want to avoid that situation. You want to make sure that it's not just the technology side of it that's really good and it's great and saves time, but it's also that it's useful for the actual people. It's actually useful and meaningful for the sysadmins in your team.
Yeah, I'm glad you brought that up because I think even more important than automation is a change control process. So even if you come out of this deciding not to automate anything, a change control process is not optional in any environment. You need to understand who made changes, where they made those changes, and like you were saying earlier, you got to be aware of what someone's intending to do before they do it by meeting with the team. Hey, this is what I think I want to do, or send an email out. This is what I'm up to. Um, because eventually, even if you're a small shop, it's going to get to a point where you're going to have to implement change control. That's obviously another topic for another day, but just keeping informed of what's going on, I think, is very important. And continuing, we have to talk about the elephant in the room. Okay, we talked about a repository and that being important. But as we talked about in many episodes on this podcast, it's way too common for extremely secret things to find themselves in repositories. So it could be a password, an SSH key, worse, an API key. You think that you would never do this, but it's too easy to make this mistake. You got to make sure you keep these things out of the repository. But with automation, though, sometimes things do need to be within reach of the automation system. Now, I'm still not giving you permission to put API keys in a repository, okay, no matter what encryption you're using. But, if you think about encryption, Ansible has something called the vault, which you could use to encrypt files, in which case you want to make sure you keep that passphrase out of the repository and anything that could benefit open source intelligence. So if you think about if a threat actor gets a hold of your repository, they have blueprints for your infrastructure. They know what port your SSH server is listening on if you changed it. They know where your file structure is. They know your config files, where they're located. They know what user accounts are on there. This is a major open source intelligence treasure trove. So even if it's something that's not that secretive, let's just say, for example, it's an SSH config file and you didn't even do anything but just deny root access and make it so that password authentication is not enabled, which is great. And you might think, well, that could be in clear text. It's fine. Really? Because, that if the threat actor gets a hold of that config file, they know every single value and setting in your SSH server. So if there's a flaw in any one of those things, they might be able to find it. So obviously keep your repository private. But even with that, just try to think about if this falls into the wrong hands, what could that mean to an open source intelligence level? And when we say open source intelligence, we did an episode on this. That's those are details that are accessible easily, that can paint the picture of how you've designed things, that can then act as a map for a threat actor to navigate your infrastructure. So utilizing things like encryption, and whatever, and I'm sure all of the solutions have their own equivalent of Ansible Vault. I think that's really important. You got to keep that in mind. It's not just the API keys, although yes, that's the most important thing to keep out of there. Just everything's a blueprint, so you just got to keep that in mind.
Most of these tools supports things like environment variables from the session where it's run. So if you don't want to hard code stuff in your scripts, which you shouldn't, look into the environment variable stuff. You'll just set them on the session before you run the scripts, and then the scripts know about them and use them, and it's never stored anywhere permanently. At least it doesn't get pushed into the repositories. Most of the tools have ways to use those, so look at that.
Now, there's a bonus. I agree completely. There's also a bonus tip I wanted to throw out there that's specific to Ansible, which is why it's a bonus tip. Don't sleep on Ansible Pull. Ansible Pull is a feature of Ansible that not everybody knows about. Normally, the way that Ansible works is you have what's called a control host that makes outbound SSH connections to the servers that it's managing. So if you have 100 servers, then you might have an Ansible server, so to speak, that's making those connections. Or maybe you have more than one. Maybe you have an Ansible server per environment, which would be even better. But that also is a single point of failure. But Ansible Pull is kind of like reverse Ansible. And when I switched to this, I just could not switch back. So basically with Ansible Pull, you give it a Git repository as an argument, which goes right in line with what we're talking about using version control. And Ansible Pull is able to manage, it's able to maintain or be run from the server local host. which for me personally has worked out a lot better. Now, the challenge with Ansible pull is it considers everything localhost. So your web server is localhost, your database server is localhost, and it's too easy to get into a situation where every server has the same config. But by using it's the -I, inventory, and then using your host name as a variable, you could still have per server configurations with Ansible pull. So depending on the name of the server, for example, maybe you have a naming convention, you could still have an infrastructure that's different per host when all the servers are pulling from one place. So now you don't have a server to maintain. And yes, you could argue the Git version control server is itself a single point of failure. It's a lot less likely if it's a private server on GitHub or GitLab for there to be a problem, although it could still happen. But for me, I maintain everything with Ansible, even my workstations. But what if my laptop is in my bag and it's asleep? Well, it doesn't matter, because as soon as it wakes up, it's going to activate. It's going to check in and download the latest version of the repository if it's changed, run it locally. So I don't really have that problem. And I talk about this a lot in my Ansible course, so I won't mention it too much here. And also, there's free videos on YouTube as well where I also talk about this. But don't sleep on Ansible pull. When you install Ansible, you automatically have Ansible pull. It's Ansible-pull, and it's right there in your path. You already have it. And what you do is you give it -U and then the repository where your playbook is stored. It's looking for a file called local.yml, which is going to be what it runs. And then on my end, I use that as an index to all the roles that then get applied per host. And obviously that, to go any more detail than that, is going to be, another hour, but I just will leave it at this. Take a look at Ansible pull. You might still find, if you are an Ansible user, that this may not be something for you, but at least be aware of it. And I think it's something that you might even like. I tried switching back to the control host method like 2 or 3 times and ended up going back to Ansible pull every time. So definitely check out Ansible pull. If you are an Ansible user, at least be aware of it, because it's like this secret feature in Ansible that isn't really as well documented, that I highly recommend you check out.
It's particularly useful for very large deployments. It saves on the resources on the main host. So
Yep.
yeah, take a look at that.
Yeah, especially for someone like me that used to use a Raspberry Pi as a control host, and I would see the I/O, and I thought, oh, it's just SSH. It doesn't matter. It'll be fine. And I'm like, oh my God, look at the load average on this Raspberry Pi. It's through the roof. Those SSH connections really do stack. So that's a great point. So, and there's so many more things that I could go over, but I think I should stop it right there. It's already over an hour episode because I just can't stop talking about automation. But I really hope that the tips that we gave really helps people out there be more successful with implementing automation, or maybe we gave you some ideas you could use in something that you've already rolled out. Either way, we hope it was helpful.
Yeah, at least we gave you some tips for things that you might not have considered yet.
Yep.
Again, thank you very much to everybody who joined. As always, it was a pleasure, and until the next one.
Thanks for joining.